All right, welcome to the Explainer. This is where we take really complex stuff and, make it make sense. And today, we are cracking a code that pretty much affects all of us, car insurance.
Have you ever just stared at your car insurance bill and thought, how on earth did they come up with this number? It feels totally random, right? Well, it's not. At the end of the day, insurance is really just a big game of predicting risk. And today, we're going to pull back the curtain and look at one of the biggest factors they use to figure you out.
So, to get to the bottom of this, we're going to put on our detective hats. Yep, we're becoming data detectives. We've got our hands on a real-world sample from an insurance company, and we're going to use it to hunt for the connection between how long you've been driving and how much you pay.
Okay, so here it is. This is our case file. We've got 8 drivers completely at random. And for each one, you can see 2 things: how many years they've been driving and what they pay each month. Now, right now, it just looks like a bunch of numbers, right? But trust me, the clues are all in there.
All right, Section 1, searching for clues. Now, what's the first thing any good detective does? They survey the scene. For us, that means we need to get these numbers out of a table and into a picture. We've got to visualize this data to see if there's a pattern hiding in plain sight.
And boom, here we go. We've plotted our 8 drivers on a scatter plot. So along the bottom axis, that's years of experience. And going up the side, that's the monthly premium. Every single one of those blue dots is one of our drivers. Now we can see all the evidence in one shot. So, are you seeing what I'm seeing?
Yeah, exactly. Look at that. These dots aren't just scattered randomly all over the place. They've got a direction, right? You can totally see this downward slope. The drivers with less experience over on the left, they're paying more. And as you move to the right, as the experience goes up, the premium goes down. So our first hunch, it was spot on.
Okay, so seeing a trend is great. It's a huge first step, but it's not enough, It's not precise. So the big question now is, how do we take this cloud of dots and turn it into an actual tool we can use to predict things? What we really need is a single, straight line that can just slice right through the middle of this data and tell us its story.
And that, my friends, brings us to our next step: drawing the line. We're not just drawing any line, though. We are on the hunt for the one, the single best line that perfectly captures the trend we're seeing. This, right here, is the absolute heart of what we call regression analysis.
Okay, now deep breaths. Don't worry about the formulas themselves. We're not going to make you do the math. But I wanted you to see them because these are basically the secret ingredients. These equations are what take all of our individual data points, munch them all up, and spit out the 2 magic numbers we need to draw our line: B, which is the slope, and A, which is basically where the line kicks off. And there it is. This is the big breakthrough in our case, folks. This is the line of best fit. Just look at how it perfectly captures that downward trend we saw. And even better, look at the top. We have our equation. The premium is equal to 76.66 minus 1.55 times the years of experience. We've done it. We've found the code.
So, okay, we've got this fancy equation. But what does it actually mean in the real world? It's time to crack this code once and for all. This right here, this is the whole ballgame. That number, negative 1.55, that's the slope of our line. And it's the single most important clue we found. What it's telling us is that on average, for every single extra year of driving experience you get, your monthly premium drops by about $1.55. That's the secret. That's a fantastic insight, but as good detectives, we have to ask, how strong is this clue, really? I mean, is driving experience the only thing that matters? Of course not. So, how much of the variation in price is actually explained by our line? How much of the story are we really telling here?
The answer? 59%. And that number has a name. It's called R-squared, and it's basically a report card for our model. It tells us how good of a job it's doing.
So what does 59% actually mean? It means that almost 60% of the reason why some people pay more and some people pay less for insurance is explained simply by their years of driving experience. That's actually a huge deal. But it also tells us that the other 41%, that's caused by other stuff. Like your driving record, the car you drive, where you park it at night, all that. So our model is really useful, but it's not the whole story.
Okay, we're heading into the final act of our investigation now, putting it to the test. Because any good detective theory has to do one thing. It has to be able to make predictions. So let's take our shiny new formula and see how it holds up. Let's imagine a new person walks in the door, a new suspect, if you will. This person has exactly 10 years of driving experience. All we have to do is plug the number 10 into our formula and see what it spits out.
And there you have it, $61.18. This is what it's all about, right? We took a messy cloud of data points and turned it into a specific, concrete prediction. But there is one last nagging question we have to answer. Could this all just be a fluke? A total coincidence?
To figure that out, we have to run one final test. Think of it like a trial. On one side, you have the null hypothesis. This is the prosecution's argument, saying you just got lucky. There's no real connection here. It's all just random chance. And on the other side, we have our theory, the defense, saying no, the connection is real. More experience really does mean lower premiums. Our job is to see if our evidence is strong enough to prove our case.
So statisticians have this cool tool. This curve basically shows you what random looks like. See that big hump in the middle? That's where most random coincidental results would fall. But if our result is so extreme that it lands way out in the tails, in this area they call the rejection region, then that's a huge sign that what we found is the real deal. This is it, the moment of truth.
And the verdict is in. Our test statistic, the final score for our evidence, is negative 2.937. And where does that fall on the chart? Way out in the rejection region. It's not even close. What this means is we can officially, confidently reject the idea that this was just a fluke. The relationship we found is real. It is, in the lingo, statistically significant.
So, there you have it. Case solved. Let's quickly run down the key takeaways from our investigation. First, we proved it. More experience is linked to lower premiums. Second, we built a model that can actually predict a premium. $61.18 for a driver with 10 years on the road. Third, we know that experience explains a whopping 59% of why premiums are different. And finally, and maybe most importantly, we know this isn't just a coincidence. It's real.
You know, today we cracked the code on car insurance, but this exact same kind of detective work, this kind of analysis, is happening silently all around you every single day. The price you pay for a plane ticket, your credit score, it's all being run by hidden models just like this one. So the question I want to leave you with is, what other parts of your life are being guided by hidden data?